Good afternoon, everyone. Welcome to the session 2 of Blockfuse Lab Cairo Bootcamp 2. My name is Oluwakemi Atoebi. I'll be your mentor for today. I go by Aramide on Twitter for anyone who wants to follow. Today, I'll be taking us on a deep dive into Cairo programming. I believe Manu had already established most of the things we'll be using for today's class, such as the installation of Scarp, and then like a walkthrough or general overview of what Cairo programming language is and why it's unique. So today, let's just go into that. So if you have any question, please just drop them in the income messages. I will attend to your question so that we don't disrupt the flow of the class. And today we'll be treating writing your first Cairo program. Then we'll also talk about data types and structure in Cairo. We'll talk about control flow and functions in Cairo. We'll also talk about Cairo data structures such as array, tuples, and structs. Then we'll end the class with solving a bit of Starkling exercise, and you also have the remaining part as your homework, because I would employ us all to try as much as possible to have our own devoted personal study for Cairo, because the Cairo book is rich, and 2 hours will not do justice to going through all of what we have in the Cairo book. So just take out time to study it yourself. You can do a peer-to-peer kind of thing where you become accountable to another peer, and that would help you in your journey to being a Caironaut. So now, to the first section of the day, which is writing our first Cairo program. So I'll be taking us through process of doing that. We can either do that by creating the Cairo program with Scarp new, or you can just do that by initializing Scarp in your own existing folder. So I'll be making use of my VS Code. You can make use of whatever code editor works for you or your terminal. But for those who are newbies, I think they will be familiar with VS Code. Is someone trying to say something? So now to the first method of scaffolding our first Cairo program, we'll start by using the Scarp new and then your file name. So I'll go to my VS Code, then I'll open my terminal. You can code along with me, or you just listen and then go through it all by yourself. But it would be nicer if we can do it together, so that whatever challenges you encounter, we can all solve that together. So now this Cairo tutorial is a folder on my computer. I opened it using this method, open folder. So you can also do that. I want all of my Cairo programs to be in one single folder. So I'll be creating a new Cairo program in this folder. Let me zoom in on my terminal. I hope it's okay like this. It's ridiculously big. So to create a new Cairo program, I'll start with Scarp new, the name of my file. We all understand that when you start learning a new programming language, you always start with the print hello world, and that is what we'll be doing today in Cairo. We'll be printing out our own first hello world as our first Cairo program. I will call the folder, the file, my file name, hello world. In Cairo, when it comes to naming convention, Cairo makes use of the snake case, which is your words with an underscore, something like what I have here. So I will click on enter. So now we have 2 options, which is either the StarkNet Foundry, the default, or Cairo test. Since we are just writing a bit of Cairo code, not a smart contract, we'll be using the second option, Cairo test. I'm coming. I want to check the income message if it's not that somebody has a question. So now, I have my folder for Hello World. This is my Cairo program folder for Hello World. And in this, we have we have our source folder, and we have the scab.2.mail. So now all of your Cairo contracts, all of your Cairo codes goes into your source folder. You can see in it we have the lib.cairo. By default, your compiler understands that this source folder is meant for your Cairo code because of the extension. We know that in other programming languages, right, we have extensions such as .html, .css, .js. For Cairo, we have .cairo. And any file that has that extension of .cairo should go in your source folder. Usually, you're supposed to also have like a test folder, and also this scab.tml, which is your configuration your configuration file. For those of us that are familiar with front-end and the likes, you know this package we call package.json, right? It handles all of your dependencies, all of your script command and the likes. What package.json is to like your front-end project, that is what scab.tml is like to your Cairo program. It handles your packages, your dev dependencies, and the likes. So now we'll be writing our first hello world. So we'll come into lib.cairo, do a Control A because we don't need all this yet. We'll take it out, then we'll write fn main and then print hello world. Okay. So now this is our first Cairo code. We are printing out hello world. I'll be running this code. Okay. Before I can run this code right, I need to change the directory into my hello world folder. Otherwise, the things I do will not reflect. So now I'll change directory into hello world. Yeah. So now I'm in my hello world directory. So I'm going to run scab build. So now for every time you run your scab build, you always get back a target folder. And in that target folder, you have a dev folder that holds your Sierra.json. So now I've been able to build this piece of code. Now I want to execute it. And to execute it, I'm going to run scab Cairo-run. And then wait for it. Now I have my hello world printed on my terminal. All right. So now that is for the first part using this scab new method. Now imagine I have an existing folder. Let me create a new folder. Let me call it Blockfuse _ Cairo. All right. So now in this particular folder, right, I don't have anything yet. Peradventure, you might already have other files in it and you don't want to create a new scab new project and then start transferring your file. You can use this other method for it. So I need to change. Let me split my terminal so that I can use. I need to change directory out of this. And then now I need to change directory. I'm back into the main folder, which is Cairo tutorials. Now I need to change directory into the Blockfuse underscore Cairo folder. So I'll do cd Blockfuse underscore Cairo, then click on enter. Now I've successfully changed my directory to blockfuse.cairo. The blockfuse underscore Cairo is still empty. So all I need to do now is scab init. So this will initialize scab for you. Okay, so now let's open. You can see now we have our source folder, we have a .git ignore because Git gets initialized in your project. And then we have the scab.toml. So the same thing we did with the first hello world. We'll come here, take out this, and put our function, this function, in this. If we run all of the command we did initially, it will still work as expected. The only difference is just the approach, not the method. The approach that, oh, you already have an existing folder, you have your files in it, you don't want to start from the beginning, or you don't want to copy and paste your existing files into a new project, you can use this other method. Or if you don't have an existing folder, you can create it afresh using a scab new, then your file name. So let me just build, scab build. Now I have my target folder and its elements. So I'll just do a scab run, scab Cairo run. Let me change the string. Okay, still the same thing, but hello Blockfuse. Yeah. Let me run again. Let's see. All right, so we get back hello Blockfuse. And that wraps up our writing our first Cairo program. We are going to data types and structures. So Cairo is a statically typed programming language. This means that the type of every variable must be known at compile time before the program runs. Just like in many other programming languages, every variable in Cairo has a type. Let me take out this guy. So just like in every program, in other programming languages, every variable in Cairo has a type. But this type you can either declare it explicitly by adding the type annotation to it, or the Cairo compiler would infer the type for you. So you either declare or the compiler would infer it for you. So we'll be discussing these two types of data types we have. In Cairo, we have the scalar types, and then we'll have the compound types. Under the scalar types, the reason we call these scalar types is because they take single values. Is either a particular variable name is equal to a single value, not multiple values. And we have three types of these scalar types. We have the FEB252, we have the integers, and we have the Boolean. Some of us might be familiar with Booleans already. The value of a Boolean is usually a true or a false. So now, if you have a variable, let's say a variable that you are calling is verified, that variable can either take just one single value, but it cannot take true and false at the same time. That is what makes it a scalar type. So to the Boolean type, it is usually represented with the keyword bool. and its value can only be true or false. It cannot be 0 or 1. It can only be true or false. And Booleans are generally 1 FEL252 in size. We would come down to FEL252 and then try to explain this part again. So when we are talking about the felt type, FEL252, in Cairo, the default data type is FEL252. And this stands for field elements. This FEL252 is an integer that ranges between this, that ranges between this value, where P is a very large prime number that is equal to 2 raised to power 251 plus 17 times 2 raised to power 192 plus 1. If we do this math together, we realize that this number called FEL252 is a really large number. But this only sets like the upper limit for this type, right? There are certain instances whereby you can have like a number that doesn't fall within the range of a FEL252. This can, when this occurs, it can either cause an underflow or an overflow. Now, let me explain the concept of this underflow and overflow. Let's imagine we have a number range of 0 to 10. We don't have -1, we don't have -2, we don't have any number that goes beyond 0. And we don't have any number that goes higher than 10. So someone does a computation, and now they are getting, let's say, the computation is 8 plus 4, which is equals to 12. This is way beyond the range that we currently have. So that is an overflow. So in this kind of situation, right, FEL252 has like an arithmetic that it does in such a way that it knows the appropriate multiple of P's that needs to be added or subtracted to make sure that this number that is now falling out of range, which is an overflow, a 12, is going to come back and fall within range back to 10. And also the same way, let's imagine someone is trying to subtract 3 from 2, we get a -1, which is below the range of 0. That is on an underflow. There's also a mechanism in place to ensure that this gets wrapped back within range. But this underflow and overflow is a vulnerability which you don't want to like have in your code, because if an hacker can understand this concept, he can figure out this concept in your code, they can find a way to leverage on that vulnerability and ensure you pay dearly for it. So that is that for FEL252. It's a really large number, but peradventure, a number goes out of range of its scope, which is a FEL252. It can either cause an overflow or underflow, and then it wraps back within range. So now, how does felt differs from integers, since it's a number figure, right? It's a number type. So now, the biggest difference is in its division, right? Now, when it comes to dividing in normal programming languages, if you decide to divide 2 in 6, you get 3. If you decide to divide 5 in 2, you get 2.5, which is a floating number. But in Cairo, right, when you have situations like that, you would get a really weird number. But this weird number always satisfies the answer that when you reverse it, it would become the same result. Now, let's say, for instance, 11 divided 2 in 11, right? That is 5.5. In Cairo, you would get a really weird number, but the result you are getting, if you times it back by 2, it will come back to 11. This is due to the way its modulo arithmetic is being done. So Cairo's division might return a number that looks strange, but it is mathematically correct in the world of field elements. So what makes felt different from an integer, since they are both number types, is just its own method of division. So now moving on, we also have the third scalar types, which is the integer. To represent your felt, to represent a felt type, you use the felt 252 like this. You write it like this whenever you are dealing with a felt type. So now it's an integer. Whenever you are dealing with an integer, you either use the u and then the number of bits you'll be using, or the high and then the number of bits you'll be using. I would explain this. In integer types, we have two different types. We have the unsigned and then we have the signed integer. Now, integer type itself are all numbers, no decimals allowed. Unlike felt 252, you know now, felt 252 differs from an integer based on its division, the way it does its division. But the integer also differs from felt 252 because of added security features that has been put into it to provide extra protection against potential vulnerability in your code. So the issue of underflow and overflow that may be prevalent in felt 252 cannot occur in integer because that security feature has been built into it to avoid such vulnerability. So now, I said something about your integer type, the u or the high, having a particular number of bits that it would use. So as a programmer, when you are writing your code, you might have an idea of the number of bits you want your integer to store. So now for unsigned integers, which are usually positive numbers, they don't take negative numbers, you can have U8, which takes 8 bits. You can have U16, which takes 16 bits, U32, U64, U128, U256, and then the U size. The U size is just the U32. All right. Now, all of this from U8 to U128, they can all fit well into a felt 252. But U256 cannot fit well into a felt 252 because 252 and then 256, if we do the subtraction, we realize that a U256 needs 4 more bits to be able to fit well into a felt 252. So Cairo under the hood, U256 is divided into 2 parts, the low U128 and then the high U128. So U256 is the only unsigned integer that doesn't fit into a felt 252. So now to the signed integer, which is usually represented with the I, this represents both a positive and a negative value. But its sizes ranges from I8 to I128. So moving on. So we just finished treating the scalar types, which includes the Boolean, the integer, which is a number value that has the extra features of dealing with vulnerabilities like overflow and underflow. And then the FEL252, which is Cairo's default data type. If you at any point in time while you're writing your code, you do not specify your type in your variable, it gets defaulted to a FEL252. So now let's talk about string types. For those of us that are familiar with programming language, we know that string types are usually the text type, the words type, the character types. But by default, Cairo doesn't have a native type for strings. But it provides two ways to handle them. It provides a short string and a byte array to handle this. We all know that in other programming language, right? Let's say for instance, let's say JavaScript, you use both, you can use the double quotation or the single quotation in your code and it works fine. But in Cairo, it works different. For you to use a short string, you make use of a single quote, right? You make use of a single quote, as seen in the example, in this example. It is an ASCII string, that is, each letter, this is what an ASCII table looks like. Let me escape this because I needed to open that. This is what an ASCII table looks like. It ensures that every character, every letter has a number, right? So now, this means that each letter is turned into a number using this ASCII table and then stored in a FEL252. For instance, we have this ABC, right? Let's go to the ASCII table and then check it out. You can see all of this, uppercase A to uppercase Z, and these are their numbers, right? Now we have symbols, and now we have the lower cases. We have lowercase a, and this is it. This is the number 61. We have lowercase b, 62. We have lowercase c, and then that is 63. So coming back to this, by the time we translate, we write ABC to using the ASCII table, this is what we get. 0x61, which is a number on the ASCII table for A, 62, and then 63. So this is how Cairo handles string, the first method, by using short string, which usually takes just a single quote. But this particular short string cannot go beyond 31 characters. Each letter in this string is 1 byte. And we all know that a byte is equal to 8 bits. So if we divide 8 in FEL252 is 252 bits. If we divide 8 in that, we'll get 31 and then remainders. So this particular short string cannot go beyond 31 characters. But while you're writing your code, what if you need a longer string? What if you need something more? Then that is where byte array comes in. This allows you to undo longer strings. And for you to write this, it is different from short string because it uses a double quote. It uses a double quote. So peradventure you have a particular variable that needs a longer string, then you make use of the byte array. But one thing Cairo does when it's handling byte array is to break it down into smaller chunks, right? So a byte array is broken down into a byte 31 words, where each word contain 31 bits of data. So now, this byte 31 word contains 31 bits of data, which is almost like a short string, or a short string, because a short string is also taking 31 bytes rather of data. So now, any other leftover, peradventure, your other words are not up to the 31 bits that will be fit a byte 31 word, then they are left in a small buffer in a file 252. The moment it fills up, imagine you have a 4-byte data that is not up to 31, so it stays in this small buffer. It fell in this thing in a file 252 till it grows into a 31 byte data, and then it moves and becomes 8 by 31 word. But if it's not up to 31 bytes, it stays in the buffer. So these are the two ways Cairo handles string type: the use of short string and then the use of byte array. So moving on, let me go back to my slideshow. I hope you guys can still hear me. Are we together? I'm coming. I need to get that feedback to be sure I'm not firing blanks. Okay, thank you for that. Thank you for that. All right, back to. So now we've talked about the scalar types, and then we also talked about the string types. So now we are talking about the compound type, right? Now, I said that the scalar type are those ones that just take a single value. But when it comes to compound type, they usually take multiple values. They usually take multiple values, and we have the tuples, the units, and then the fixed size array as types of compound types. So now let's talk about the tuples. A tuple can hold multiple values of different types in a single array. It can hold multiple values. It's just like the opposite of an array. A tuple would hold different types of data, but under a single variable. It usually has a fixed length. Once created, you cannot add or remove any items from it. Now, it's also useful for when you want to group related values together. So we'll be talking more on that when we get to the array. So now, for you to write a tuple, right, you need a parenthesis, the circular one, or what we call the brackets. That is what tells your compiler that you are dealing with a tuple. Now you declare your variable, let data, and then you give the type that you want. The first type is a U32, the second type is a U64, the third type is a Boolean, and then you assign it to a value. The U32 value is 10, the U64 value is 20, and then the third value is the Boolean, which is true. Or you can also declare it this other way, whereby you have different variable names for access, so that whenever you want to access the variable, right, you'll be able to access it on time. So you have different variable names, you have the type, and then you have the value. So a tuple is basically using a parenthesis to write your data type. Now we have the unit type. This unit type is an empty data type. it returns nothing in Cairo. The unit type, it returns nothing in Cairo. And it is usually represented by an empty tuple, which is an empty bracket like this, or an empty parenthesis with no element. Its size is also always 0, and it doesn't exist in the compiled code. But sometimes you wonder why bother having a unit type when it's really not doing anything. But for instances where in your code you are returning something you are returning an empty data type or value, by default it becomes a unit type. So you might not necessarily use it in your code, but while writing your code, you might have something like that gets used. So moving on, we have fixed size array. So for those of us familiar with other programming language, we know that array also take different multiple values. But in Cairo, these multiple values must be of the same type. Unlike what we have in tuple, whereby your multiple values are of different types, in an array, it has to be of the same type. So if you are using a string, it's going to be a string all through. If you are using an integer, it's going to be an integer all through. Not like a mixed blend of what we have with tuple, where you have a Boolean, you can have different types, but all still holding the same multiple value under a single variable name. So when we talk about fixed size array, these are array that before compilation, the size of that array is known and it's not going to change. We also have dynamic array, whereby peradventure you don't know what size of data you want or you'll be expecting, then you can use that. But if you know the size of your data, then you use a fixed array. Now let's say, let me use the instance of days of the week. We have Monday through to Sundays. Now they are fixed. Is either Monday, or it's Tuesday, or it's Wednesday, or it's Thursday, or it's Friday, or it's Saturday, or it's Sunday. There is no other day in between. We all know that it's going to be 7 days in a week. Now you can use a fixed size array to undo that. Also, looking at the month of the year, we have 12 months constant in a year. You can also use a fixed size array to undo that type of data. Now, for you to declare an array, you declare an array using a box, a boxed bracket rather. So now this is an instance. This is an instance of using a box array. You start with declaring the name of your array. You start with declaring the name of your array and then the type. Sorry, give me a minute. I want to be sure this is not coming from Blockfuse. Okay, it's not from Blockfuse. Please, if you have any question, because it seemed like we are all quiet, please kindly drop it in the in-call message. I would attend to it. And then there's nothing like a stupid question. Please, if you don't know it, just ask. And then don't be intimidated by anybody. Ask your question. You're here to learn for yourself. So now you declare the types for your elements, and then the number, the fixed number. So this particular array variable, which is called array1, is going to be a U64 data type, and it's going to have 5 elements. So now these are the elements, integers 1, 2, 3, 4, 5. Those are the elements. So you can also initialize it this way, whereby if you know you have like the same elements, rather than duplicating same elements over and over and over again, you can write it this way. Now the recurring element is going to be the number 3. 3, 3, 3, 3, 3. It doesn't look good when you write it like that. So you can just use this shorthand method to write it. This is going to be the element, and then it's going to be 5. It's going to contain same elements and same element of same value. So you are writing it like this. So now, okay, I think somebody has a question. Let me check.
Yeah, good afternoon.
Yeah, good afternoon.
Please go back to the slide. I have a question based on the slide.
Okay. On this?
Yes. I'm kind of confused on that, on this explanation. So
okay, what part, please?
On that second array, which use A as the variable name. So kind of confused on the explanation.
Okay, this particular array, right?
Yes.
Okay, no problem. Let me just go to VS Code and explain that better.
Okay, thank you.
I wanted to use a note. I don't know if this thing is more compatible. Let me use this. All right. So let me just use this. I'm not compiling it. Now, this is what I mean, right? Don't mind the ziggly red line. I know the code is not correct. So now, by default, this is what A is supposed to be like. 3, 3, 3, 3, 3. Are you seeing this, Obed?
Yes, I'm seeing it.
All right. So now we just have 5 elements with the same value. It's looking funny because they are not different. But Cairo is providing us like a better way of writing something like this. Even instead of you having to like repeat yourself 3, 3, 3, you just write it this way. First, the recurring value, and then the number. So this 3 is the same value for all of the elements, and it's still going to be a fixed size of 5. 1, 2, 3, 4, 5. So that is what I mean by this. Did you get that?
Okay. Yeah, let me get it straight. So instead of using the value type, you are actually using the value itself to kind of represent it, right?
Sorry, I didn't get that.
Instead of using like giving it an unsigned integer here, we are adding 3 here. Now, in the place where you want to declare the
No,
array,
I can give it the type. That doesn't stop anything, right? This is just like a shorthand for writing this. I can give it the type. It doesn't stop anything.
Okay, now I understand the line 5. I understand it now. So instead of you writing it like this
exactly,
okay, I understand it now. Thank you very much.
So instead of writing it and just repeating it, and then your code is looking kind
yourself.
Okay. You said?
Yeah, thank you. Okay, I understand it now. I understand.
All right, no problem. So let me just comment this out so that the red line can rest. Okay. So now this is another method whereby you can use to like initialize your array, especially when you know that it's going to have the same value of the same fixed size, and then the same fixed size is going to have the same value. So All right. So there are different ways to like assess a fixed size array, right? You can assess it by, first of all, deconstructing into multiple variables. Let me do this on VS Code instead. Let me use this one. Okay. So now this particular array does not have like a variable name. So for me to be able to access, let's say the index 2, index 3, index this, index that, I can do this. First of all, create let's x, y, z, a, b equals to, no, I need to take out this. Equals to a. So now I can come down and okay. So now, if I want to access an array that doesn't have like a declared variable name for itself, I can do this by, first of all, deconstructing it, ensuring that each position has like a named variable. So now the first position is taking the variable name x, the second position is taking the variable name y, the third position is taking the variable name z, the fourth position is taking the variable name c, and then the last position is taking the variable name a. So now all I need to, b rather, and I'm binding it to this array, this variable array a. So now all I need to do is just print any of those variable names that I want to access. So if I want to access y, if I want to access this, if I want to access that, I'll just print out so I think I should print this. So whichever one I want to print out, right, I'll just print it out. I'll just pick out the name that I want and then print it out. And it's going to fetch it from wherever position it is. So we can access array either by using the deconstruct method, or we use a span. When we get to array T, we'll talk more about a span. But for now, it's just another way for us to like index an array. So when we get to that, we'll talk about it. I have to be conscious of time because we still have a lot to cover though. So let me just continue. All right. So moving on. In Cairo, we also have type conversion, whereby you can convert a particular data type to another data type. But there are two methods by which you can initiate this. You can either use the into method or the try underscore into method. Now, you use this into method whenever you want, like whenever you are sure that this conversion is going to succeed. And an instance of you being sure that your conversion is going to succeed is if you are changing, if you are changing, let's say a smaller type to a bigger type. You are changing a smaller type if you are converting a smaller type to a bigger type. For instance, you are converting, let's say, if we all know that a unit 256 does not fit into FL 252. So now you can imagine you converting a FL 252 to a unit 256. That would work fine and it's guaranteed to succeed because a smaller type is being converted to a bigger type. And so that is where you use the into. You can see what we have here. A U8 is being converted to a U16 type. And this is it. You first declare your variable name, the type, and then the value. Then you bind it again to, and then, sorry, the type, the value, then the one you are converting to, the type, and then you bind it to your previous variable using the dot into as well. So now for the try into, you use this when your conversion might fail. For instance, you have an important part of your code that if it doesn't work, you want it to be obvious, like your code to either fail or panic or something. Then you use the try underscore into. Now, let's say, for instance, you're trying to convert a big type to a small type. Converting an unsigned integer 256, a U256 to a for 252, which is a conversion that might fail. So now, most times when you use a try into, it returns an option. If it returns an option, so you need to unwrap the results. The option could either be like, okay, it's successful or it's not. So most times you have to unwrap this option. There's I think in array I treated these unwrap options, so we'll talk about that as we progress. So when it comes to type conversion in Cairo, you either use the into or the try underscore into method. If you are sure that your conversion type is not going to fail, you use the into. But if your conversion type might fail, then use the try dash into method for your type conversion. So that is that for data types. We still have I would like I said, I would implore us to try as much as possible to not just take class on the surface alone. Try to also go through the Cairo book yourself to better solidify your understanding of all of this concept, because most of this concept is just an overview. We cannot do like a full scale deep dive due to our time frame. So now we'll talk about functions and then control flow, right? Now, in other programming language, we always say functions are like blocks of reusable code. It allows you to, like, rather than having a long line of just variable names and actions outside of it, you can put all of this together, put it in a function, make it reusable that in such a way you can use it in different scope. That is what functions does. And in Cairo, when you want to define your function, you start with the fn keyword. Other programming languages can use the full function keyword, but in Cairo, you make use of the fn keyword. And just like in other programming language, after your keyword, you have the function name, you have the parenthesis, and then you have the curly braces. Now, for Cairo, the naming convention, like I said initially, is the use of the snake case, which allows you to use underscore with your naming. So after the fn keyword, you have your function name, you have your bracket, as seen in this example, just like when we wrote what we wrote in a Cairo program, fn hello world, the brackets, parenthesis, and then the curly braces that will hold your code logic. Everything about your function logic is going to be within the curly braces. Now, for you to call a function, you call a function with the function name and then the parentheses, which tells your compiler that you're trying to call a function. I don't know if you have understand. So now, This empty parenthesis is basically for your parameter, your function parameters. So you might be writing a function that requires inputs from users, then you make use of your function parameters. Let's say, for instance, I have a function add underscore u8. I've declared my parent. I need two parameter. I want to add two numbers, the x and the y. So now I'm passing in the parameter and ensuring that I pass in the type as well. So x colon u8 and then y colon u8, then the block of code. So parameters as special variables are part of your function signature. Sometimes you hear people use parameters and arguments interchangeably. In itself is not so wrong, but parameters are what you have in your function, like the special variables you've declared in your function. Now, when a user passes in the inputs, then that is the value they provide is the argument. But most times you see people use parameter and arguments interchangeably. So for times when you need extra inputs for your function, you make use of parameters. And while you use these parameters, right? For instance, this function add u8 has two parameters. Whenever you are calling the function like this, add u8, you need to pass in the value. So my x could be 5 and my y could be 10. So that when that function gets called, it gets the argument that it needs to execute the function. Okay, so we can also have named parameter. This can be achieved by specifying the name and value. Let me use VS Code to explain this, right? Let me just take out this guy. All right. fn add underscore u8. So I can decide to, okay, this one worked. Let me try this. So let's x equal to 10. Let's y equals to 12. Right? Then I'll just pass in these parameters like this. I can add the type u8 and on like that. So sometimes you can have named parameter that you want to pass into your function. So if you intend to like have named parameter, you can declare, first of all, you declare that named parameter, give it a value, and then you use it in your function. So moving on. So now let's talk about statements and expressions. So when it comes to statements usually does something. It could be like, let's say you are creating a variable, you are defining a function, but what makes a statement different from an expression is the fact that it doesn't return a value. It usually ends with a semicolon. So now, for every time you declare a variable, you end it with a semicolon because you're not expecting it to give back a value. Whatever doesn't give back a value is known as a statement. But an expression is anything that gives back a value. It's any part of your code that produces a value. It can be part of a statement in the instance of when declaring a variable. let's say a variable x is equal to 10. An expression can be part of that statement because the value that is being returned back from the x is the 10. Calling a function is also an expression because when you call a function hello world, the intention is to have it print hello world on the console. When you call a function add, the value you are expecting in return is that it has two number and then gives you back that value. So calling a function is also an expression. And whenever you want to like initiate an expression, you do not end it with a semicolon. You do not end it with a semicolon. You just leave it. Let me show us an instance. Let me quickly spin up something. All right, let me get this one out. I know we are really pressed on time, so I'll try as much as possible to be fast about these. But I just want to show us this. Please, whenever we are also alone, we can try all of these things out. I would explain this. I'll explain this later. Now, for now, let me just. Well, it's, coming. Now, this is what I mean by, now when I declare this variable, I ended it with a semicolon, which signifies that this is just a statement. Now, this expression, I want to return the sum of these two numbers. I want to return the sum of these two numbers. So I'm ending it with an expression because I need a value to be returned back to me. So now I can do this. I'm coming with this work. Let me take this out. So I would call the sum, the add underscore unit, and then passing the numbers I want. 12. Why is this one acting like this? Okay, so let me run this. I hope I'm in this one. What did I make? Why is it not working? Okay. Return an empty array. So I want to do this. Let me use this one. Okay, yeah. And see what I'm doing wrong. Sorry, guys. Let me use this guy. Yeah. Okay. Now let's try it again. So now the value of the sum is being returned as 22. So now basically your statement ends with a semicolon. Your expression does not end with a semicolon because it's expecting a value in return. So back to, we have 15. I have 15 minutes. Let's say 20 minutes left. So brush up. So now I said I was going to explain that the return value, right? So to return a value in Cairo, you must declare its type using an arrow and then this. Whenever you are returning a value in Cairo, you'd have to use this. It's only by adding this that it shows that you want to return a value. If you don't add this and then you just come and then write your code properly, it's not going to run. So these two, the arrow and then the type, are symbols to show that yes, you want to return a value in a Cairo function. So yeah, a quick pause. Yes, a quick pause. I believe some of us might be aware of the ongoing hackathon in StarkNet's ecosystem, the Reignite hackathon. So we would really like to encourage you guys to apply for it. Sorry. We'd really like to encourage you guys to apply for it. The hackathon started on the 12th of May and is going to run through to the 26th of May. So you can test out your knowledge by applying for this hackathon, form a team. You never can tell, maybe that idea you've been nursing is going to be like a next breakthrough into StarkNet. I am a big part of the StarkNet ecosystem, and I've seen hackathon projects move from just being hackathon projects to actually getting seed grants. So try to be a part of this. You could also be a recipient of StarkNet seed grants, or you could also be a winner of the hackathon. So guys, apply. If you are feeling you're a newbie and you're not ready yet, apply, join a team, or be part of, or request to have people on your team, and you'll be shocked at what can happen. So guys, apply for Reignite Hackathon and go and do awesome things. So my next slide. Now let's talk about control flow. We still have something. Let me see how many slides I have. Okay. So now when we talk about control flow, right? This is when you run your code based on certain conditions. In other programming language, just like we have in other programming languages where you have your if-else statements, your switch statements, all of these are just a way for you to run certain block of code when certain conditions are met. So now in Cairo, we also have the if statement, and then we have the else if statement. For the if statement, if checks a condition, if that condition is true, it will run a particular block of code. But if that condition is false, then it will optionally run a block that has the S block, or that is if you have like an else block. If you don't have an else block, then it won't run anything. So now let's say, for instance, you're trying to sift through, you have a variable number for age, right? And you want a case whereby if someone is not up to 18, then they can't come into your place of business. So you attach this condition that if a person is not up to 18, then they shouldn't be able to come into your place of business. So you come down to your code. If age is not equal to let's say if age is not equal to 18, you print go back home. Else, You are welcome. Now, in this example here, we have a number that has the value of 3. So if this, we are now, we have a condition now that says, okay, if number is equal to 5, then it should print condition was true and number is equal to 5. Or else it should print condition was false and number is equal to, and number is equal to rather 3. So now we all know that from the example here, we understand that the number is 3. So the if block is not going to run because the if block is checking if the number is equal to 5. But the else block will run and then it will print the condition was false and the number is 3. So now we also have the else if, right? Peradventure, you have like multiple conditions that just the if else might not be able to accommodate. You can then make use of the else if statement. Now, using building up on the previous example we had, so now we have let number equal to 3. So if number is equal to 12, print number is 12. Else if number is equal to 3, print number is equal to 3. Else if number is equal to this, to 2, if number minus 2 is equal to 1, print number minus 2 is 1. Else print this. So you can have as many conditions as you want, but Cairo would only execute the block for the first true condition. Every other one, even if you have like 3 truths, would be ignored. So imagine you thinking if you have like multiple conditions where you have four returning true and then the others returning false. Cairo would only execute that first block that is true. The other remaining 3 blocks that would have been true would get ignored. So it is advised that you don't cramp up your multiple conditions into itself else if. Besides, having a lot of else if looks kind of ridiculous because there are always a better way to go about it. So now to the next one. So for conditions in Cairo, we have the if, the if statements, the if of, and then we have the else if statements that can accommodate your multiple conditions, which is strongly not really advisable to have too many conditions. Then for still on control flow, we want to talk about loops. Now loops are generally like a way for you to repeat to keep executing a particular code. There could be a certain condition in your code whereby you want to just keep executing that piece of code over and over and over again. Cairo helps you achieve this by using a loop. So in Cairo, we have 3 types of loops. In Cairo, we have 3 types of loops. We have the loop, we have the while, and then we have the for loop. Now, the loop in itself makes use of the loop keyword, and it will keep running forever unless you either break it manually or you break it by using the break keyword, or by setting a gas meter, or by using the continue keyword. So that when you use a break keyword, is like you are setting like a condition that when it gets to a certain place, then the loop should break. If you don't have that condition in place, then your loop just keep running. Then you can also use the continue keyword, whereby a part gets skipped to, and then it moves to like the next execution. Or you make it, or use a gas meter on your terminal by running available gas flag. So let me try let me try the first loop. Okay. Let me revert back to Okay, let me just take this one out. Please, I hope we are together. I'm coming back to get that. Okay. So now I want to make use of the loop keyword. Loop. Okay. So now let me run this. Okay. You can see it keeps running and running and running and running. Let me terminate that so I don't get into trouble. So now you can see my loop just keeps running. And I had to end it. You can see it's just endless. I had to end it using by killing the execution. So if you use your loop like this, it will run till infinity. It will just keep running and running, and then it would, that would be a disadvantage to you. But when you are writing your Cairo smart contract, certain mechanisms have been put in place to avoid you writing codes that would run into loops like this. And that is the concept of gas, right? If you write a smart contract that will run in loops, then it means you have sufficient funds to pay for gas. So peradventure, when you finally run out of gas, then the loop will stop. So let me use the gas meter method to this available gas method to cause a manual break in the loop rather than an endless one. So I'm just going to add this and then add, let's say, 200,000. Okay. Yeah, this should work. All right. So now I add almost like a condition to when the loop stops manually, and that I achieved by adding this available gas, a gas meter to it. I added 200,000 available gas meter, and all I have here is just 8 LOWs rendered compared to the endless LOW I had initially. So the loop ended with out of gas, so means I am out of gas. So in using this keyword, you can use the break, the continue, and then the gas meter to ensure that it doesn't keep running. But when it comes to a while loop, right, a while loop is that loop that runs as long as a condition is true. While loop is that loop that runs as long as a condition is true. And for the for loop just loops through like a collection of things. It's for the for loop, it is more cleaner when you use it than for the while loop. You can all go through this yourself, because right now we have just 13 minutes left and I still have quite a lot to cover. So now when it comes to control flow in Cairo, we have the conditional statements like the if statement and then the else if statements. And when it comes to like repeated execution, Cairo makes use of loop, and it has 3 types of loop: the while, and then the for loop. So moving on, we'll be moving to array, tuples, and structs. We already discussed tuples, so I'll just be going through array and struct. I'll try as much as possible to wrap up fast so that we can do a bit of Starkling exercise. I don't know if any, are we together, please? Can we get a Cairo material? Yes, Maui. Sorry, I don't want to. I don't want to call your name in a very bad way. So, yes, the Cairo book is like a go-to resource for everything you need. I think I dropped it initially, but let me drop it again. Everything you need about understanding Cairo. I'll drop the link for you about understanding Cairo. Please refer to the Cairo book. As they always say to developers, right? Documentation is your friend. It might not really look pleasant, but it helps you go really far when you settle down and sit with it. Yeah, sorry, when you sit with it, rather. So just make use of the Cairo book, and then you have all that. You are all set to becoming a Chironaut. All right, let's talk about array tuples, and then we'll go to Starkling exercise. We have so now talking about array. Initially, when I was explaining the fixed size array, I talked about array being as a data type that takes multiple values of same type. Right? It takes multiple values of same type, but array in Cairo is quite different from every other programming language. Let's say, for instance, in JavaScript, you have the shift, you have the unshift, you have the pop, you have the push, whereby you can either push from the back or from the front. You can add to an array either from the back or from the front. You can take away from the array from either the back or the front. But with Cairo, it works different. You can, when you want to add elements to an array in Cairo, you can only add to an element from the back. And then when you want to take out from an element in an array in Cairo, you can only take out from an element from the front. So now, if you want to create a new array, now we're not talking about fixed size array, we're talking about the array T. This is how you create. This is how you create a new array trait. Then the colon, the new, and the bracket. Now, let's say, for example, right, I mentioned earlier that whenever you want to add to an array, you add from the back. The method that you use in adding to an array is called the append method. The append method. So now, in this example that we have here, we have an array named A, and then we are using the array trait new to create the array. Now we are now appending to each array, starting with a.append 0, a.append 1, a.append 2. Right? So now when it comes to variables in, I was supposed to mention this when we started the class, just touch a bit on variables. When it comes to variables in Cairo, by default, they are immutable, meaning that they cannot be modified or changed later on. So, but Cairo provides a way for us to like mutate or change, make modifications to certain variables, as long as you are using a keyword called mut. As long as you're using this keyword mut. And the reason we have this keyword in this is because we are appending to this array. We are making modifications to this array. If this keyword is not there, then your code is going to run into an error. Then we also have the constant keyword, which moves your variable from just being immutable by default, but to permanently being immutable. Like you cannot do anything to a constant variable. So please, you can also go through that the Cairo book. So now, I said that an array takes it allows two operations, the append and the append that allows you to add to the end of the array. And then we have the pop underscore front. Now, this pop underscore front allows you to remove from an array from the front. Now, looking at what we have, let me just quickly use an instance of. Now, let's say this array A U624 is equal to. I just want to use any array. I just want to use an instance. I'm not using the array traits just to show us. So now, every time you use the append, it comes to the back here and then append to this 6. If you append again, it comes like that, whatever number you're appending to it. So now, if you are using the pop underscore front, then it comes forward, takes out this. Just taking out this. It comes forward, takes out the first value. Then if you call that method again, it comes again, takes out the next value, and on and on and on like that. So those are the only ways you can modify an array in Cairo. From the back, add from the back, take out from the front. So, what did I do? All right. So moving on. We still have 27 slides. Okay, almost done. All right. So now, when you want to access an element in an array, right? You can use two options, the get option or the at option. So now, talking about the get, right? This allows you to safely access an element in an array by an index. It returns an option box T, which means it either gives you some box, a smart pointer to the element at the given index, or none. So now, I said something about option types, right? That you have to like unwrap an option type because it either gives you like what you want or nothing. Either gives you what you want or nothing. So you need to unwrap it to be sure what value you are getting. So now when you use this get index method, it also returns this option box method whereby now you have to unwrap and then you have to unbox the result. The reason this method is quite different is because even if it doesn't return anything, rather than your code running into a panic, it's going to return none for you. So let's say, for instance, you have an array that has just two elements, 0 and 1 by index. Now you are requesting to access an array at index 3, which doesn't exist. If you are using the get method, it will return a none. It won't panic. But if you are using the at method, it will panic. So moving on, let's go to the at method. So now, the at method usually provides direct access to an element in the array by index. Now, this at method is a method you use when you are so sure that that particular index exists in your Cairo program. Unlike the get, it does not return an option. Instead, it assumes the index's value is valid and returns a box snapshot of the elements. So what the at is getting is, you're asking the at to get you a particular index, and that is what it wants to do. So if it doesn't see that particular index, then your code panic and stops. But if it's the get, then it will return a none. It will return none, which is nothing. So depending on what condition you have attached to your array, you can use any of this method. If you want a case whereby if that index is out of range, you want your code to stop because that particular index is that particular part of your code is really important to you, then you use the at. But if you just want it to either return none, then you can use the get. So now, just like we have in other programming languages where you want to get the length of elements in an array, in Cairo you make use of the len method. The len method, with that you can get all of the elements in an array. So comment. All right, we are almost done. Okay, I think I would have to like rush through the last set of slides because I want to stop this in 5 minutes so that we can do a bit of Starkling exercise and then show you how to get started on it. It's really important we do that. So now to the array macro. So this is used to create arrays with value that are known at compile time. Let's say, for instance, now for all of the examples we've been doing, right? Come in. Let me show us this other example. So now, for this example that we did, we made use of the append method. That we were appending each value to the array. But now this array macro allows you to declare that value and to declare the value of your array before compile time. So this is what it does. You declare your variable let array equal to, then you declare the array macro, and then what value you want, 1, 2, 3, whatever value you want, you declare it. So it gets picked at compile time. Now I said I was going to touch briefly on span when we talked about fixed size array and how we can convert a fixed size array to a span. So a span is a struct that represents a snapshot of an array. It is like a read-only view of an array. So it allows you to perform every other array method except for the append method because it's just a read-only view. So it lets you look at content of the array without changing anything. This is useful when you want to share or use the array in another part of your code, but you want to be sure that it stays the same. So, for you to turn an array into a span, you call the .span method on it. You start with the name of your array variable, and then you call the .span method on it. So quickly to struct. Yeah. So yeah, struct is similar to tuples in terms of holding multiple values of different types. We know that the tuple holds multiple values of different types, and then it holds it in a parenthesis. But when it comes to struct, when it comes to struct, you need a name for each piece of data, so it's clear what each value means. However, struct is more flexible than tuples. We said that tuples basically are fixed in size, and then you must follow like the order whenever you are declaring, whenever you are giving back, whenever you are updating the value. But when it comes to an array, because it has like a named piece, you don't need to follow the order in which your variables are declared. So now in declaring a struct, you start with the keyword struct and then your variable name. For instance, this example we have here, struct user. We have in struct user, we have username, which is a byte array for longer string. We have the age, U128. We have the email address, which is also a byte array, and then we have verified. All of this named piece tells us what the value means. We are declaring a struct of user, and all of this value it declares like a property of what's an important part of the user's life. So for us to be able to instantiate a struct, you can instantiate it like this. Please, you have to go through all this yourself. I'm out of my time is up. So you can instantiate a struct like this, or you can instantiate it making use of another instance of struct. But using the other instance of struct, it only allows you to just make few changes. So that is something like this. So there's an existing instance of a user struct, and now I'm creating a user 2. The only thing I'm changing in that user struct is just this email, and I'm using every other variable in the struct. To access and update a struct, you make use of the the dot notation. For those of us familiar with other programming languages, the dot notation is when you do something like you pick the name of your variable name and then dot that property you want to update its value. So I believe we'll come to the end of today's class. We'll be going to hands-on session with Starkling exercises. So Starkling app, for those of us that are not familiar with it, let me just show us what it looks like. So this is what Starkling app is. For you to better understand and then have like hands-on session with while learning Cairo, you make use of this app. Let me drop the link for us. This would help you to better practice and then fully understand Cairo. And it's mostly part of requirements for graduation. I don't know for Blockfuse, but it's mostly part of the requirement for graduation for you to have completed your Starkling app exercises. So yes, you connect your GitHub. It would ask you to authorize like a third party authentication with your GitHub. So just honor that request or the permission, and then you can start coding. So let me just log in with mine. Okay, so I won't be using this because I've completed mine. So there's really not, and there's hardly anything that would change. Yeah. So now this is the first exercise, and in this exercise, just an intro to Cairo. This is a function with just a function declaration. It's not doing anything, but we are asked to compile it. So you compile. And then it works. It tells you to go to the next. So it tells you to go to the next. You go to the next. It shows you what you need to do, and then you keep on doing that like this, like that. So I'm done with my own Starkling exercise, so I can't use this. Let me go to the GitHub. All right, let me start with variables because that's the next. After this intro, the next one is variables, followed by primitives, and on like that till you get to the end. So try to register yourself on this app, and while you are going through the Cairo book, just try to get hands-on experience doing that as well. So let me go to variables. Yeah. Now, this one says, the variable says, make me compile. Make me compile. All right, so I'll copy this and then I'll use Cairo, what I spinned off as. Yeah, I'll use this. Let me take out this. Let me take out this ones. So yeah. Okay. Now this is talking about variables. Guys, please go through variables yourself. In declaring a variable in Cairo, we have the let keyword. So that is what I will be using here. I'll do this and then we'll try to see if we can do the others together. We'll just try to see if you can just think through some of the tags and figure out what is wrong with the code. So let me run this. Okay, let's see. And then sometimes for you to like maybe get an hint of what is happening, you can just run the code in that ways. And then try to understand the error message to know what you are doing wrong. So now the error message say could not compile due to previous error, this is pointing to this. Identifier not found is pointing back to this. So now you know your error is from this. So you give it an identifier let, and then you come back and then run the code. You wait for it. So now X is 5. The code runs successfully. So let's go to the second one. Please, are we together? Do we have any question? Osai. Osai. Do you have a question or was that a mistake? Okay, no problem. So now we have the variable for the second one. It says, let me just copy it to VS Code and then the only thing is I can't get to see our face. I can't get to see our responses when I copy the code to VS Code. So now what do you guys think is wrong with this particular function? Like, what do you think is wrong with this function? It looks fine, but it won't compile. Let me put it in so you see. All right. This X is being flagged. So what do we think is wrong with this code? And how can we fix that error? Anybody? Anybody? Okay, James. James, you have the floor.
Okay, I think from the function, we declared X, but we did not give it a value, and now we're saying if it's equals to 10. So it won't compile because we're not giving it should I say, we're not giving it a value, we're just declaring it. So for it to compile, we need to do something like let X equals to maybe 7 or 8.
Okay, let's do that. Let X equal to 7.
Yeah.
Okay, now let's run. So it works. James is correct. Thank you so much, James, for that. Then let's go to the next one, which is variable 3. All right. So now we have this function. It also looks like nothing is wrong with it. So let me copy and put in VS Code. Then we can check it out together to solve it. We'll solve it together. We still have 5 minutes. Okay, so what is wrong with this? What is wrong with this code? What is wrong with this code? Anybody? So you guys want only James to solve it all for us? Eh? You want only James to solve it all for us? If James is the only one solving it, then it means it's only James I'm going to give my stack to. So I don't know for the others.
What's the question again?
What's wrong with this code? What's wrong with it? Why won't it compile? Why
And
won't
there's
it
no equal to where you wrote let x colon felt. Okay, it is not initialized.
Sorry, I didn't get that.
Hold on, I'm coming, please.
All right, no problem. Truth, we are still waiting. You have 3 minutes left. Any other person on the call or any of our AI representatives, at least they've been in the meeting since, so they should be able to answer some questions. All right, James.
Okay, I think the last person that spoke was kind of trying to answer it. So I think just like the last one, it's basically the same thing. It's just that this we declared the x, so we just put we give the x a value. So let's say let x equals to 10 or anything.
Okay. He
Like
said
let
he
x
answered,
equals
but he said
yeah.
I should give him a minute, and then he didn't say anything again. So let's compile again. Okay. So truth, you were actually correct, but I just wanted you to be confident about it, about your answer. So yeah, it didn't compile because it didn't have a value. So now on to the next. Okay, I think that should be the third one. Oh, we've done the third one. Fourth. All right, so now to the fourth one. Let me copy it first and then come back to, yeah. Okay. So now this one has certain rules. It said we should not change this line. So what do we do? Yeah, truth.
So the issue is that x is not mutable, so we have to declare it with let mute x equals to 3 for us to be able to change the value later.
All right. So now what truth said, by default, I said Cairo variables are immutable, right? But Cairo provided a way for us to like modify or make changes to certain variable by using the keyword mute. So if you are not using the keyword mute and then we leave it like this, it sees you trying to change the value of an immutable variable. So let's compile. All right, so that works. Yeah. So let's do one more before we wrap up the class. And all right, so now to this one, let me copy it and just put it in VS Code. All right. So now this also has its own rule. It says don't rename this variable. It says don't change this line. So what is wrong with this code? So what is wrong with this code? Anybody? So Charles, James, and Truths are the Cairo legends in this class. Yeah. Okay. James, you have the floor. James?
Okay, can you hear me?
Yeah, loud and clear.
Okay, so I think this is just about the shadowing, because in Cairo there's what we call shadowing. So we're trying to change the number. So the only thing we do is just add let to that other number, to the line 8, just add let.
Let's. Yeah. Yeah, you're correct. So guys, we've come to the end of today's class. Like I said, Cairo book is too vast to be covered in just 2 hours. We can only try as much as possible to like give a brief overview, but with your own personal study, you can get more you can get more understanding on the whole concept that you are being taught. So please, guys, the ball is in your court. Keep putting in the work, and we expect to see you shine in StarkNet's ecosystem. Thank you guys for joining the call. Thank you for having me as your mentor.